So there's a few more things that I want to just sort of park in the back of your head. These are not things that you're going to use very frequently, but they do exist. If I want to use more advanced try branching, I can actually use specific errors that come up to give specific feedback. Let me show you what I mean by that. So when boy, everything's behaving so weird today. Disconnect. I'm just going to restart old PyCharm here. Maybe that'll help it out.
I think
maybe not. Okay, so let's just say I want to convert the word hello or the string hello to an int. If I just run that one line of code, the rest of this is commented out. So I just run that one line of code. Okay. So the error type that I get is a value error. It's a value error. That's the name of it. So if I get a value, let's say I want to capture that value error. I'm going to put this in a try, except print generic error. This will work. It's just going to give me a generic error. No matter what the error is, it's going to say generic error. But if I want to capture that value error specifically, I will add here except value error. And this will happen only if I get that specific value error. So now print you can't convert a string to an int. So now it's capturing that specific value error. Okay, and if I give it a different kind of error, it still catches it. It doesn't give me the red text. It doesn't crash my program. You can see that my program still exits with exit code 0, which means that it didn't crash. It just finished executing. So this produces a different kind of error. What kind of error does it produce? Well, the easiest way to find out is just to make it throw that error. So I'm going to say int hello plus 8. That error is a type error. So if I want to find out if I want to capture the type error specifically, I can say type error here like that. Print you can't add those. So now I've captured my type error. So I'm giving feedback that specifically pertains to the type of error that I'm producing. And the usefulness of that allows you to give better feedback to your users that will help them understand what it is they're supposed to do. Have you ever been using a program on your computer and you click something and it just says like error and that's all it says? You're like, cool, that is completely useless to me, right? So you can avoid doing that by capturing the type of error that you anticipate. It does require you to go a little bit deeper in anticipating what your users might be doing wrong, but it does help you because you can make better programs that say specific things like you need to enter this instead of that here. So that's what we're wanting to do here. That's the goal of naming errors like that. And the sandbox today will actually help you recognize what some of those errors are by playing around with things and trying to produce errors in your code. The other thing you can do is you can use try, except, and else. Okay, so else only runs if there were no errors. So it'll run whatever's in try, and if it gets all the way to the end of the try block and no errors produced, it will run this. That's useful for wrapping up whatever it is your program was supposed to do or whatever you wanted to do next. You can also use finally. Finally is run no matter what. If there's an error, it will run. If there's not an error, it will run. So this is done no matter what. So if try works, it will run this. If try doesn't work, it will run this, the exception, and then it will run this. So the big use for that is when you're writing to a file. If you get an error in the middle of writing to a file, the big danger there is that that file will not be closed properly, and then the file could be corrupted, which will prevent you from using it down the road. Corrupted files are a big mess. So finally is often used so that if we're trying to write to a file, if it doesn't work, it might give you an error message, but you still need to close the file so you can make sure that that happens here, so that no matter what happens, that file gets closed